Okay, so quadratic inequalities, so we're back in grade 11 for just a second. We can solve them graphically or you can solve them algebraically. Now I know we haven't done a lot of graphing yet, and so we're going to end up doing it algebraically mostly, but let's look at a picture first and see what it really means, what we're solving for. So this is the graph for x squared minus 4. So what does it mean graphically to solve the following inequalities? So what does it mean if I said x squared minus 4 has to be greater than 4? Let me put some layers on here. Okay. Sorry, it has to be greater than 0. So greater than 0 means this line. So it's greater than this line. Well, that's the x-axis, right? So what we're looking for is when is our quadratic greater than 0? When is it above? Okay, so that would be starting like around here and starting around there. And those are our x-intercepts. So this thing is going to cross at, it looks like at a 2 here, and here at a negative 2. And the quadratic is above the axis if x is larger than 2, so we get x is larger than 2, or when x is less than a negative 2. So this inequality has two regions in which it solves. If you were to put that on a number line, we would put the negative 2 first, the positive 2 second. They both get an open circle, and so greater than 2 or less than a negative 2. You just heard me use the word or, and this means it is a compound inequality. It has two answers. And then finally, in set notation, starting from negative infinity up to 2, up to a negative 2, and then starting at 2 again to infinity, and all these are round brackets because none of the numbers are included. Okay? So that's the first one. We can also ask, well, when is this quadratic, x squared minus 4, when is it less than or equal to 2? Well, the line 2 runs about here. So when is it less than or equal to 2? So what I'm interested in is this spot and that spot. And we want the quadratic to be below. And you can already see then that this is going to be an inequality that solves as an AND inequality. So the easiest way to solve this would be to finally answer it would be to solve the quadratic somehow, because if I read this off, so this is somewhere between a negative 2 and 3, and this one is somewhere between 2 and 3. So having to solve this, then I would have to think of this as a quadratic. So I would think of it actually this one first, sorry, not equals to 0 but equals to 2. Then I could move the 2 by subtracting 2, so now I end up with this, and then you can continue to solve it. Well, that's solving it algebraically, which we're going to do here in a little bit. So for right now, the best thing, or the best answer that I can give you is somewhere between 2 and 3, and a negative 2 and a negative 3. So, you know, I'm going to guess that maybe this point here was like a 2.5, and that's a guess. And this one then would be at a negative 2.5. So if those numbers are fairly accurate, then it would be a negative 2.5, positive 2.5, close circle here, close circle there, and then we connect it. But, you know, keep in mind that these numbers here are guesses. So, I don't know. Alright, last one there. When is the inequality less than a negative 4? Well, negative 4 runs over here. Okay, and when is it less than a negative 4? Well, the quadratic is never below a negative 4. Now, it looks like it touches right there at a negative 4. Okay, so it does touch, and then it goes back up. So this one, the answer is going to be never. Okay, the quadratic is never below the line y equals a negative 4. So that would be a null solution. So you could write it this way, no solutions. You could write it as the null set, or you could just say never. It changes a little bit if I had made that. So if I said, well, what if the inequality was not less than a negative 4? What if it was less than or equal to a negative 4? And now this point does become important, and now this one actually solves only in one spot. When x is 0, the inequality has an answer, because at 0, a negative 4 equals a negative 4. Okay. Okay? So that's graphically. So we don't really do this, but I want you to keep in mind this sort of picture because it helps to solve when you do it algebraically. And I'll show you that over here. Okay, so x squared minus 5x plus 6 greater than or equal to 0. Okay, so I'm going to pretend that it's an inequality or that it's an equation. I'm actually going to solve this for equal to 0. I can factor this one, I think. X negative 3, negative 2 equals 0. So the two answers that I get for equal are at 3 and at 2. Okay, and then this is why I did do the little graph. So if you were to think of this as in terms of a picture, 2 would be here and 3 would be there, and this quadratic, since that's a positive x squared, it goes up, so it does this. So when is the quadratic greater than or equal to 0? Well, it's equal here and there, and then to the left and to the right of 2. So the answers here are going to be x needs to be less than or equal to 2, or x is greater than or equal to 3. And if you put this on a number line, you would put the 2 here, the 3 here, close circles, and then if this one goes to the right, this one goes to the left, so that looks like a compound inequality, an or compound inequality. Okay. How about here? X squared minus 4x plus 1 less than or equal to 0. Okay? Well, let's see what happens when is this thing equal to 0. This one's sort of actually set up for completing the square, I think. So let's move the 1 to the other side. Makes it a negative 1. Write this as x minus 2 squared. So we take half of the 4 and then we square it on the other side to balance it. So we add 4. And so when is x minus 2 squared equal to 3? Take the square root, x minus 2 is equal to plus or minus 3, move the 2, so at 2 plus or minus square root of 3. Okay, again, we can put this on a picture, and it's maybe a little bit harder to draw, but this does have two answers. This is 2 minus the square root of 3, which would be just here in front of 0, and it's 2 plus the square root of 3, and that would clearly be the bigger one. So that would be like here, and this quadratic would still go up like this. So when is it less than or equal to 0? Well, less than or equal to 0, starting here it's equal to 0, and then ending there it's equal to 0 again, and in between that it's where it's less than or equal. So 2 minus the square root of 3 here, close circle. 2 plus the square root of 3 over here, close circle, and then you need to connect these. So there's our and compound inequality. Okay, last one. What if I made that a 4x squared? Okay, that makes it a little harder to complete the square because I'd have to divide by 4, and that works okay here, but you get a fraction and another fraction. Most of us don't like fractions. So third way, let's just use, and again, sorry, so I'm ahead of myself a little bit. I'm going to pretend that it's an equation. I'm going to use the quadratic formula, so negative b, so that would be 4 plus or minus the square root of b squared, 16 minus 4 times a times c, divided by 2 times a. So x is 4 plus or minus 16 minus 16 is 0. So that's 4 plus or minus 0 divided by 8. So that's 4 over 8, only one answer. It's a half. So it's equal to 0 at a half. So I guess that thing was factorable, right? It's 2x plus 1 twice. Or, sorry, 2x minus 1 twice. Let's look at what this picture would look like. So if that's 1, it touches right here. It's a positive quadratic, so it moves up like that. So now I got to see. So it says less than or equal to 0. So it's equal to 0 right there. Other than that, it's never less than. So the only answer here really is x is a half. So this only has one answer. If this inequality was for, let's do that in a different color. If the inequality said 4x squared minus 4x plus 1 is less than 0, well, it's never less than 0, so you would say no solutions. So it would have been that. What if it was 4x squared minus 4x plus 1 is greater than 0? Well, greater than 0, well here it's equal to 0, so greater than 0 would be everywhere other than that point. And the easiest way for me to graph that is actually with the number line like this. So it would be an open circle, right, because it's just greater, and then to the right of that number and to the left of that number. So you get just that as a graph. And then the last form of that would be 4x squared minus 4x plus 1. What if it was greater than or equal to 0? So now we get equal at a half. You would put a dot there, you would close it in, so a half is allowed, and then you would say, well, to the right and to the left of it is also greater than 0. So you actually end up with, well, that's just a number line. So that would be all real numbers. So you could say all real numbers. Okay? Well, that's it. Thank you.